Hi, my name is Jeffrey Knorr. I'm Senior Director of Product Marketing here at Panasas. We're here at Supercomputing 2012 in Salt Lake City, Utah. In September, Panasas launched ActiveStore 14, and here at the show we're demonstrating this product for the first time to all the supercomputing attendees. This is a very exciting product for us. It's our 5th generation of ActiveStore Blade storage. And what makes this product really unique is its approach to combining enterprise serial ATA drive technology with flash technology, namely solid-state disk, in a very intelligent, unified way. One of the common problems with HPC storage is that it's not really all about small files or large files. There tends to be a big mixture of the two of them. And what we've discovered, and this is maybe not new to people who are really into HPC file systems, but there tends to be a very high percentage, often as much as 70% of the files, that are very small and that take up less than 1% of the capacity of the file system. So if you have object storage like Panasas does, and you have control over where the files get stored, why not store all of those small files as well as all of the namespace, the file system metadata, on solid-state disk? And that's what we've done with ActiveStore 14. So tremendous improvements in small file performance, in any sort of directory listings and metadata activity. So a much more responsive product. But at the same time, you have the very large files throughput streaming performance that you always would have expected from Panasas. So when it comes to throughput, ActiveStore 14 is mainly about uncongesting the storage system from all of those small files and metadata. So our large file throughput is actually very similar to our previous flagship product, the ActiveStore 12. Where the real difference comes into play is the small file metadata performance. So we now scale up to 1.4 million IOPS per second for 4K reads in a large-scale Panasas system. And we can scale the capacity now in excess of 8 petabytes of storage in a single global namespace. So when it comes to the benefits for using SSD in the way that we have, a lot of people are making flash-only dedicated appliances, and those have their role for very high IOP data or database type of environments. But in HPC, where you do have the big data phenomena taking place, and a lot of the data sets are very large and require very high throughput performance, you can't afford to put that on flash. At least almost nobody can. So it's really about the intelligent use of flash memory. So we've been able to keep the dollar per terabyte side of the equation at a viable level. In fact, it's a lower dollar per terabyte than our previous products, even as we've added a small, reasonable amount of SSD into the equation to accelerate the metadata in the small files.
My name is Barbara Murphy, and I'm the Chief Marketing Officer with Panasas. I'd like to explain the relationship between Panasas and Hadoop. So Hadoop, we all know about Hadoop. Well, Hadoop is actually really a conglomeration of things, including applications that do NoSQL data queries. But the core piece that I guess the comparison with Panasas comes down to the file system, which is known as HDFS, the Hadoop file system. Interestingly enough, the Panasas file system, which is called PanFS, and the Hadoop file system, HDFS, share a common heritage from work that was done by our founder, Dr. Garth Gibson, at the Carnegie Mellon University. And we found that because of the parallelism that's common between a Hadoop type of architecture and Panasas architecture, as well as the massive scalability, we were actually able to seamlessly integrate the Panasas infrastructure into a Hadoop environment. So effective now, you can run any Hadoop workloads on the Panasas storage system without having to go out and buy dedicated storage and dedicated compute just for that Hadoop environment specifically. And we actually have a very nice white paper on our website that you can find that on. So, we serve some 3 key markets. We break down the big data market into a number of segments. Design, which is really about engineering collaboration, things like computational fluid dynamics. And these are engineering work groups who are doing very heavy data-intensive workloads, whether it's modeling or simulating. But fundamentally, the core piece is that there's a design element, and we're helping really advance the manufacturing processes within companies that are doing aeronautics, engine design, all different types of, and we actually have an interesting use case with a bicycle racing team. So lots of different interesting things where they're trying to get their designs to be as aerodynamic as possible. The other core piece that we have, which really plays to the show, is the area of simulation. And this is all about discovery, whether it's Monte Carlo simulation for finance, genomic research, oil and gas exploration, or core government type research where they're doing deep visual analytics, weather simulation or weather modeling. The third market, which ties into our Hadoop area, is people are starting to now use the HPC capabilities to do big data workloads for deep analytics. And this is taking those unstructured data workloads and running Hadoop on them to find out queries around different customer use cases or whatever. But what's core to it all is that they have this very extensive data sets which are highly unstructured. So they're the three key markets that we're addressing today for Panasas. Well, what sets us apart from the competition is if you take most of the general file systems that are out there and most of the storage vendors out there, they're dealing with what I call kind of a legacy type architecture that's very much built around network attached storage with a dedicated filer head and RAID engines behind it and then disk behind that. That architecture has been around for 20 years. It's the basis of pretty much all the NFS workloads out there. Panasas was funded through some government investment to build out a parallel file system. And there's really only three major file systems in existence. Ourselves, Lustre, which is an open source file system, and then one done by IBM called GPFS. Panasas is unique in that we've taken the simplicity and ease of use that people are used of with an appliance type of environment. You can see it here in the background. This is a very simple to use appliance. And compared to our competition in Lustre, for example, which is a very, very complex system to use and requires a lot of very experienced Lustre file systems experts to keep it up and running, you can run our system with very basic administration. So we've taken the best of that core research done by the government in parallel file systems, but we've brought it to the commercial space in a very simple to use appliance. So what's best for our environment is where you have groups of Linux clusters, and the bigger the Linux cluster you throw at us, the better we do. So we like, good size, 50 minimum cluster upwards, up to thousands of compute cores actually in a single cluster. That kind of compute environment suits us very well. Because of our parallel architecture, we have the ability to write directly from the compute client straight to disk at very, very high speed. So we get very high bandwidth. And now with the ActiveStore 14, we also have the ability to manage very high IOPS. So we can do both, small file very well, but we can also do very large file very well. And as I say, what works really well for us is very demanding compute applications where you have a time to market requirements that are critical, or you have very, very complex simulations that require a lot of compute power. We're the right solution for that. And as I say, if you are a commercial type of customer in particular, what's really nice about Panasas is it'll be a very seamless move from kind of some of the more traditional storage systems that they would be used to using. Well, we're continuing to push performance. That's always been our leadership role in the industry, is we get the most out of disks, we get the most out of networks, and we get the most of our own system at a file system level. We'll continue to deliver faster and faster and higher performing systems. We think with the ActiveStore 14 and our use of SSD, we now have a very nice play in IOPS intensive workloads, which in things like EDA or in life sciences, or for that matter in finance, where there's a lot of small file and large file environments. We see that as really our sweet spot. We think we're unique in that from an industry perspective, people have focused on one or the other. We can do both very efficiently within one box, and we think that's going to be the continuation of our investment moving forward.
So the Panasas system uses Object RAID, which is a per file data protection. When clients write data into the system, they write a little bit of redundant data. The data and the redundant data is chopped up and written to different storage blades. So each one is doing a little bit of this RAID computation. When you have hundreds or thousands of clients, it gives you online scalable RAID performance. For rebuilds, what we can do is we can break up the rebuild workload on a per file basis, and we can have different director blades on our system all work on different files in parallel. So all the director blades are doing rebuild, all the storage blades are participating in rebuild, and so With this parallel rebuild engine, we reconstruct failed blades very quickly. And in a larger Panasas system, we're going to rebuild faster on a linear basis. And so it provides excellent data protection in a large system. And it also lets you trade off the performance and reliability characteristics on a per file basis. And it's a great match for the high capacity storage systems that we use today. So we just have our 5.0 release coming out, and it supports our new AS14 storage blade. And the AS14 couples 2 high capacity SATA drives and an SSD inside the storage blade module. We call that an OSD, an object storage device. And these objects are containers for data and attributes. And we just talked about how Object RAID breaks a file up into different pieces, so each of those is stored in one of these data containers. Inside the storage blade, there's a file system, which is just a fancy data structure on disk. There are indexes and allocation maps and object descriptors and journals, and there's this fancy data structure is seek intensive. And we're going to concentrate that on the SSD, and we're also going to put small file data on the SSD so that all this stuff, which ordinarily can cause a hard drive to spend a lot of time seeking, is pulled very quickly off the SSDs. At the same time, large data extents are just going to be streamed out to the hard drives. So we're using the hard drives for what they're good for and the SSD for what they're good for, and we're not thrashing the system. And it's also all transparent. So it's transparent to the rest of the storage system, and it's automatically managed. So you just get the response time benefits of having that SSD in the system. So PNFS has been a long time coming. We've been working in the standards efforts since 2005, and we've been working hard on the open source Linux implementation for several years now, since 2006 and 7. All the bits are upstream finally in the upstream Linux kernels as about Linux 3.4. Now we're waiting for the Red Hat and SUSE distros to adopt all that code and turn it around and make it available in an enterprise Linux distribution. We expect that to happen in the 2013 timeframe, and at the same time we will start officially supporting PNFS on our server side. We think already we are multi-protocol. We support NFS and CIFS and our parallel direct flow client, and the PNFS client will be just another client for all of our data. So data that you have today that you created with direct flow will be available tomorrow via PNFS. And we're excited about that because we think that PNFS will highlight the power and features of our parallel file system. So thanks for joining us here in Salt Lake City. It's been a great time. It's a beautiful city. We had a nice, beautiful snowfall, and I'm looking forward already to next year in Denver. Thanks.